Hello, in this example I would like to show you how to transform this differential equation, how to put it into a state space form. Here we have also defined a vector of state variables, a state vector. Okay, let's begin. So first of all, we defined new set of variables that will so that we can represent our state vector. So I define x1, x2, x3, x4. So basically I rewrite it as this. This one will be equal to x1, x2, x3, x4 accordingly. Now I rewrite it a little bit differently so that I can easily see the derivatives of y. Sorry, here I use 5. As you can see here, I have y with 4 dots. That can be I can rewrite it using those variables. Fourth derivative of y equals simply I put everything on the right hand side, so it's minus 3y minus y plus 5u. In order to define this derivative of y also using my new set of variables, I can easily see, okay, second derivative of y equals to this variable and y equals to this variable. So I have minus 3 times this minus x3 plus 5u. Once I have this all defined, I can go to move further. Okay. Here I have a vector of derivatives of state variables. Why do I need it? Because the equation I'm looking for is in this form. I need to define the vector of derivatives of state variables. I will go row by row from top to bottom to define each of those derivatives using the variables I previously defined. It's equal derivative of x1, and as you can see here, I in my notation x1 x1 is simply 3 y dot. Further, I have 3 y 2 dots because of that. And finally, using this notation, I have 3 times this equals to this. Okay, I move further. As you can see, x2 equals to this prime equals to y for further derivative and equals to everything that we previously defined. Oh, one dot. First order derivative. One third x1 x4 equals 5 y second order derivative equals and this equals to 5 times x2. Once we defined all this vector of derivatives of state variables using new variables I defined previously, we can proceed as follows. Now we are ready to go into state space representation with matrices. Derivatives of state variables. This equals to our A matrix we are looking for. Our vector of defined state variables. Plus the B matrix from this equation, plus our input variable, simply U. Okay, and it goes as follows. We start with the first row. We look how x1 dot is defined. It is the function of x4 x4. As you can see in this equation, we have only x4. Therefore, here all almost the whole row would be zeros, but we only have x4. Therefore, here goes 3/5, 3/5. We go further. We move to the second equation. As you can see, here we have this most complex equation, and the fourth derivative of y is a function of x4, x3, and u. Therefore, we have no x1, 0, no x2, 0. We have x3 with the coefficient -1, and we have x4 with the coefficient -3/5. And we also have u, because this is the function of u, with the coefficient 5. I forgot to mention that here was the coefficient y, because here it's not a function of u. This first equation. Second is a function of u. We move further. Here we have only x1 defined. Therefore, we have 1/3 in the first column, followed by zeros. Fourth equation, as you can see, here what appears is only x2. It will be 0, 5, followed by 2 zeros. And here u, our input, appears only in the second equation, that therefore we fill it up with zeros. We are ready with this whole equation, but we also need to define our output equation. It will look as follows. We need our C matrix, the output equation. We go back to those equations. As you can see, y appears only here when there's no derivative. Therefore, y is simply, in our case, equal to x3. Therefore, we have 0, 0, 0 times x1, 0 times x2, 1 times x3, and 0 times x4. This is how the C matrix will look like. We move further to the D matrix. Look up to our equation. Is it a function of u? No, there is no u. Therefore, in the matrix we put 0. And here how our state space representation looks like. Thank you.